Mr. Samuel will be here to handle you guys on your physics tutorial. Please do pay rapt attention to him.
Good day, everybody. How are you doing? My name is Samuel. You are welcome to physics class series here on YouTube, and we are going to do a lot of academic work here online. I believe you are going to enjoy it. It will make you do your physics very excellently, and I feel it's going to help you in your academic work. Today,
by the way, if you are enjoying this video, then your subscription to the channel will be appreciated. Like this video, comment and share with your friends.
Today we are going to look at chapter 6 of chapter 1 of the textbook Physics and Properties of Matter, Mechanics and Properties of Matter rather. And we are starting from chapter 1. Under chapter 1 we have few things to learn here. Number 1, we are going to look at the introductions. We are going to also look at the units, prefixes, dimension of physical quantities, applications of dimension, and then those applications of dimensions include verification of correctness of formula, derivation of units of quantities, checking the relationship between quantities. So I trust that you will stay tuned, and then we'll finish this course in no distant time. Let's look at introduction. What is measurement? What do you understand by measurement? Measurement is simple. Measurement is simply comparison with standard. We have different physical quantities here that we study. We have temperature, we have pressure, we have mass, we have length. So when we measure them in sciences, we compare them with standards. That's what we simply call measurements. That means anytime we are measuring length, for example, we have a prescribed standards that we measure length against. So we have different standards out there for us in sciences. Now we also look at what is units. I have already said that we have different physical quantities. Those physical quantities are measured in units. They are measured in what? Units. Every system, as in every physical quantity, has its own units of which it is being measured. We have the units are divided into what? The fundamental units and the derived units. Fundamental units are those units that they are basic to sciences. Their definition do not depend on other quantities. Example of this fundamental units are, we have the mass. Mass is measured in kilograms. We have the length. Mass as in length is measured in meters. We have the temperature. Temperature is measured in Kelvin. We have the luminous intensity. Luminous intensity is measured in candela. We have the amount of substance is measured in mole. And then we have the time. Time is measured in seconds. So these are basically the fundamental quantities we have. But as far as mechanics is concerned, these are the ones we will mostly deal with. We are going to deal with mass, we are going to deal with length, and we are also going to deal with what? Time. So if you look at it, you will see that in mechanics, most of these other fundamental quantities are redundant. Now we go ahead to look at what are derived quantities. We say derived quantities are those quantities that has its definition dependent on other quantities. Example of derived quantities are velocity, examples are velocity. Velocity is measured in meters per second. Of course, you know that the definition of velocity is time rate of change of time. And then we have the acceleration. Acceleration is measured in meters per second square. We have the volume. Volume is measured in meters cube. So these and many more, we have thousands of derived quantities out there. What is important is that fundamental quantities has basic definition. They do not have their definition dependent on any other quantities, while derived quantities are otherwise called dependent quantities. That means their definition is dependent on other quantities. That's preferably or majorly the fundamental quantities. So those are the units that we have. Then the next thing we are going to look at is the prefixes. And in sciences, why do we have prefixes? We have different prefixes that we consider in sciences, and I'm going to write them out here so you can see them. I'll give you reasons why we use prefixes so you can also understand. Now, prefixes. Let's look at our prefixes. I say the major reasons why we use prefixes is to write very small or very large numbers in sciences. Now, when we are expressing quantities in very minute or very large or what we call extra large numbers, then we use prefixes because there is no time, there is no space for you to write those numbers. If you have decimals, the decimals can go as far as having 4, 5, 7 zeros. For example, if you have a number like 0.0002, this is too long for you to write in sciences. Or you have a number as maybe 10 million liters, this is too long for you to write in science. Maybe you have 0.0002 seconds, or you have 10,000 meters. This is extra large for you to write in science because you may not have enough space to write this. Imagine if you had to write this repeatedly for 4 or 5 times. Every time you write 10,000 meters and so on and so forth. So that's the major reasons why we use prefixes. So these prefixes are very simple for us, so you just need to learn them by your fingertips and then you use them anytime you are solving. For example, times 10 raised to power 18 is known as hexa, is always represented with E. Times 10 raised to power 15 is peta, is represented with P. Times 10 raised to power 12 is tetra, that's T. And then times 10 raised to power 9 is giga. Times 10 raised to power 6 is mega, that's megawatt. Example is megawatt. Times 10 raised to power 3 is kilo. Example, we used to have kilometer, that's 1 times 10 raised to power 3 meters. We have 10 raised to power 2 as hecto. The commonest one is hectoliters. When we talk about 1 hectoliter, that's 100 liters. 2 hectoliters, that's 200 liters. We have deca, times 10 raised to power 1 is known as deci. We have decimeter, we have deciseconds and so on. Times 10 raised to power minus 2 is centi. Times 10 raised to power minus 3 is milli. 10 raised to power minus 6, this is very common in science. We have micro, example is the microfarad. When you see something like this, you know that that's microfarad. For those of us that did some electricity in our secondary school, you see that microfarad is the same thing as saying 10 raised to power minus 6 what? Farad. So that's one of the essence of these prefix I'm talking about. We have times 10 raised to power 9 nano, times 10 raised to power 12 as pico. We also have picofarad too. Times 10 raised to power minus 15 femto, and then times 10 raised to power 18 auto, minus 18 auto. I actually start this because this is hard to come by and we use it most times, so you don't have to forget this one. This one is not very common.
Now, don't click off yet. Just check out the next video that will be coming up in our playlist.